I circled on here the ones that correspond to the free response questions. Everything else is multiple choice. Thank you for heads nodding. I like knowing that what I'm saying like landed. You know what I mean? Just stare at me. All right. So number one, average rate of change means what? Slope. All right. So you're going to need a point for -2 and a point for 1. So we're going to plug those in because you had time to work. Just tell me what you got, and if it's right, we'll move along. -2 gives you what? Yep, -11, and 1 gives you 2. Okay, good. So your regular old algebra 1 slope is -2 plus 11, and then over 1 plus 2. Now, did I circle this one? It's multiple choice. Do you think the choices are going to look like that? Probably not. So you need to keep going. All right. If you didn't, that's fine. You didn't know that. But like multiple choice is probably not going to look like that. I have seen them do that though, but usually they simplify it. So this would be 9/3, which is 30. Again, free response, you stop. Multiple choice, you got to keep going because the answers aren't going to look like that. All right, find the average rate of change on the interval -1 to 4. So you're going to use this point right here, -1 comma 7, and then 4 comma 2. If you didn't write that, you just went ahead and did the answer, that's okay. I like to write it out. That's a personal preference. It helps me see what I'm doing better. If you get the X's on top and the Y's on the bottom and it's wrong because you flipped it around, you're going to be bummed. So just take the few seconds and write it out if that helps you. All right. So 2 minus 7 over 4 plus 1. Again, did I circle this one? No, it's multiple choice, so the answers probably aren't going to look like that. What is this going to give us? Yep, good, which would be -1. Beautiful. Follow-up question. If the derivative, the slope, is negative, what does that mean the function is doing? Beautiful. All right, average rate of change is on the interval 0 to k is 1.07. Write an equation that could help you find the value of k. Same thing. If you write out the points, it will help you so much. And this one's going to look weird because we don't have any like actual numbers. There's not a function to actually work with. But if you were to plug 0 into a function, you would get f of 0. I don't know what it is because they didn't give me a function, but are you following me there? All right. And then if you plug in k, you would get functional value at k, f of k. All right, that's what it would look like. We don't know what they are, so it looks kind of silly, but do you get what I'm saying? You don't have to do anything. All right, and then if you set up that slope, it's going to look like this. Again, it's a lot of rewriting the same thing over and over again, but it wasn't actually hard. So my pep talk is, you can do it. It's not hard, it just looks weird. And then you would set that equal to, well, what did they say to make it equal? Yeah, 1.07. So that's the answer. It should look like that. I know that looks weird, but yep, no, it just looks like that. We didn't actually do anything. You know what I mean? It's all symbols and notation, and that's what gets people in calculus. The math part is actually easy. It's the notation that's a mess, right? Average rate of change on this interval. So which piece of the function are we going to plug 1 into? Yeah, the top one, that would be 1, right? And then 3 is bigger than 2, last time I checked. So if you plug 3 in here, what is that, -4? All right, so sorry, I'm kind of flying through this part. Did this go okay? So is that -5 halves? Cool. All right, on our way. What do you notice about this one? I circled it. This is going to be a free response one, so you have to actually write out your answer. So given this graph, for how many values of A from -5 to 5? So you're only going to look from here to here. And unfortunately, the hole punch is like through there, right? But we're only looking at that part. Is the average rate of change, so if you connect 2 points, equal to 0. So starting at -5, that's right here. How many different points can I connect to where I will get a slope of 0? 2. And which 2 are they? Yeah, this one and this one. Now you can write those out if you want, but it didn't ask you for what the answers are, just how many answers are there. So there are 2 values where slope is 0. And this is going to look similar to that other one we did where we didn't actually like really do anything. Again, if it helps you to write these out as points, then do that. Bless you. You would have -5 comma f of -5, and you would have a comma f of a. If that doesn't help you, don't bother. I'm just writing it. If it does help you, then it only takes 3 seconds to write. Just write it. So there's two values where slope equals 0. I know it's going to look funny, but what will this be for us to do a slope between these 2 points? How will it start? Well, f of a, good, minus f of -5, good, over a plus 5. And I want to set that equal to, what did it say in the problem? 0. So there's 2 values where that slope equals 0. It's worth 2 points. 1 point for saying there's 2 values, the answer, and then 1 point for the explanation using a slope formula. Cool? Okay. Using the same graph for number 5, so we're still going to use this guy right here. Is there a value? Okay, so in essence, it's a yes or no question. Is there a value on -6 to 2? So we're only looking at that interval such that, what does this thing mean? I asked you and you answered me. What does this mean? That means derivative. That is your definite, you took a quiz on it. That's your definition of a derivative, instantaneous rate of change. Is there a value from -6 to 2 where that derivative is 0? I think it wasn't last time, but maybe the time before, where you were finding all the like 0 tangent lines and the vertical tangent lines. You remember that? Think back to that practice you did. Is there a place on this graph where our derivative would be 0, our tangent line would be 0? So the answer is yes. And then your explanation is where it is. And where is it? Do you guys see it, -4? Do you see it right here? How you would have a 0 tangent line? So again, 2 points. 1 point for saying yes. And then this is your explanation. If you say where it is, that's an acceptable explanation. All right, number 7, there's not a question that makes you write out all these forms of notation, but I put it on here so that you know what they all are, so that in a question, no matter which way they write it, you know what it means. A derivative can be written f prime of x, or it can be written y prime. And then does anyone remember the third one? Oh, good, nice job. So they're always impressing me. Again, there's not going to be a question where you have to just write these out, but you need to know them in order to do other questions. So I threw them on the review. The one you did on your quiz, how does it start? I want the definition of the derivative. Guys, I drew a little cloud around it up there. It's literally on the paper. There we go, limit. H goes to 0 of what? Try not to look at it. What is it? You have to know it. F of x plus h minus f of x, the function, over h. Now that gives you f prime of x, the derivative at any point, and then you can plug in anything you want. Do you remember how on the quiz I gave you some follow-up questions? Plug in 2, plug in -7, whatever it was. Now there's another one where you can jump straight to the answer. That one is limit x to c, and c would be like a number, all right? And then of what? F of x, the function. It's slope, right? Slope formula. If you forget what you're doing, slope. The answer to every question in some capacity is slope. That's rates of change is what calculus is. It's a study of change. I read once that the area of your brain that processes change is right next to the area of your brain that processes pain. I don't know if that was true or not, but I did hear that. So like change is painful. Calculus is like literally you're studying change. Yeah, I don't know. I just think it's funny. All right. Find f prime of 0. We're going to have to do limits from the left and the right here because it is a piecewise function. So we're going to do limit. Did you do limits from left and right? Great. Limit x goes to 0 from the left. Which piece of the function do we use if we're going from the left? Yeah, the top one. X squared minus 7. That's the function. Minus whatever you get when you plug in 0. So what do you get if you plug in 0? Yeah, -7 over x minus 0, or just x. There's actually not much to that, because what's going to happen there? As I'm looking at that, it looks like most of it goes away, right? And those 7s cancel out. And then what? What are you left with at that point? Yeah, x squared over x, which is just x. So kind of all disintegrated. What's your answer? Yeah, 0 is your answer for that one. If you plug in 0 for x, you just get 0. I know that felt really basic. That was one of those situations where it gets so easy that it's harder because it's like what happened to the whole thing. All right, now we're going to go limit x goes to 0 from the right. Which piece of the function do you use for that one? Yeah, the other one, right? I'll take that. Minus whatever you get if you plug in 0, which would be 5 over x minus 0. So a really similar thing is going to happen with that one. 5s cancel. You're left with 3x over x, which would actually just be what? 3. Okay, so what's the overall answer to the whole question? Does not exist. Why does f prime of 0 does not exist? Don't match up. Perfect. Follow up though, because I don't remember how it came out on the test. Say they both came out to 3, then the answer would just be 3. Say they both came out to 7, then the answer would just be 7. If they don't equal each other, that does not exist. Good. It's multiple choice, so it literally doesn't matter. Oh, to the function. If you plug 0 in for x right here, you just get -7. If you plug, it was weird because it was 0, so it feels like nothing happened. If you look back in your notes from that section, we did ones that had an actual number that wasn't 0. It makes a little bit more sense. Yeah, go ahead.
So if we're trying to find the derivative, then we're going to use the one with this one.
The h's, yes.
But then when will we plug in the x plus h's? Because that's defined just the slope.
That's to find f prime of x. So you would end up with a statement like f prime of, like on your quiz, it was f prime of x equals 2x plus 5. I don't remember what it came out to, but something like that. And then you could plug in numbers to get the slope at those particular points.
So it's just like this.
You get
oh my God. X plus h, but
the directions are going to let you know.
Okay.
So I think you're overthinking it. Step back a little bit. The directions will tell you. Don't overthink that too hard. All right. Oh, this one is circled, guys. FRQ. Function represents a car driving away from home. F is in miles, X is in hours. I usually circle my units, miles and hours, right? Approximate F prime of 2. Derivative means what is it? Slope. Okay. We want the derivative at 2. Now I have this actual point at 2, but I don't want that one. I want to pick the ones around it. I wasn't here for this lesson, which makes me really sad because I bring it up all the time. Do you remember the Alice going for a walk lesson? I bring up Alice and her walk all the time because it applies to so many things. Do you remember how we took 2 points and then we brought it in? I say we as though I was here on the video. But do you remember how we didn't use that actual point? We used ones on either side, closer and closer? That's what you're doing. So these are the 2 points we're going to use to do our approximation at 2. So again, if you don't want to write this part, fine. I like to, though. It helps me keep the X's and Y's separate. It takes 3 seconds, right? So then what? What am I going to write? 160 minus 45 over. Do I have to simplify? No, so don't. If you do it wrong, it will be wrong. All right. Now, we're not quite done yet, though, because what does it say? Interpret the meaning. I circled the units, put it together, use your common sense. You've got it. Miles per hour. So like in a sentence form, what's going on? You know it. You're smart. You've got this. Just in a sentence, what's happening?
For every 2 hours, it will like increase by 100.
You are overcomplicating it. Just forget this for a second. You're going for a drive. The car is going whatever miles per hour at time what? At 2. Okay. So the car goes, or the car is going, I should say. The car is going, whatever this is, miles per hour at time 2 hours. You want to write it the simplest way possible. And if you ever get confused, oh my gosh, what's going on? I feel buried by information. Step back and just go, I know what a car is. I know what movement is. The car is going whatever miles per hour at time 2 hours. Okay. I'm not going to do a break. I'm going to keep on. This is like normally where I do a break, but I don't have time to play games. So we're going to keep on going. Yes. Mm-hmm. The only things that we've done so far, I think they wouldn't take. Don't write diff for differentiable. I don't think, or CON for continuous, but they'll take INC for increasing, stuff like that. Like all the basic ones. B/C for because. Yeah, go ahead.
So even though it's the derivative, like I'm trying to do it, so
yes, because we're up. That's a really good question. Can you guys hold on a second? Do you see how it said find the derivative? We didn't actually find a derivative. The reason we couldn't actually find a derivative is because we didn't have an actual function. All we had is this table of values, so we had to approximate it. Cool. That was a really good question. Because the difference between actually finding something and approximating it is, it's good to know the difference. Right? Using this graph and the tangent line shown, what is f prime of 2? Derivative means slope. What is the slope of this line? That's all you've got to ignore the parabola. You don't need that. What's the slope of this line? Close. -2. Down 2 over 1, like in algebra 1. That's it. That's it. All right, let f of 0 equal 7. Once again, I would write it as 0, 7. It takes 1 second, and it just will help you not get confused about what's going on. F of 0 equals 7. Use the graph of, oh, what's that the graph of? Derivative. That means slope. What is a tangent line equation? What 2 things do you need to write an equation? Yep. Slope and a point. We got a point. We just need the slope, which is going to come from this graph. Where is our point of tangency? At x equals 0. Watch me point to this because I don't have a better explanation than here. Look. At 0, 3. Now put it together. Good. Equals? Now, I don't remember because I can't remember everything in the world. I'm really sorry to disappoint you all. It might be written like this in multiple choice, but say they distributed the 3 and added over the 7. Could you do that and pick A, B, C, D? Okay, I don't remember how it's written. I can't remember everything. I know, I'm sorry. I'm such a disappointment. All right, the function f of x has a tangent line equation at x equals 1 of this. You don't have the actual graph, you just have the tangent line. All right, so just to give you a visual, just pretend your graph is a parabola and this is your tangent line. And then it's at the point 1 comma something. If you don't want to draw that, fine. I'm just trying to give you a visual. A visual can help sometimes. Why did I draw it going downwards though for my visual? Negative slope. Good. Okay. So it says evaluate the following. F of 1. How do you think you would do that? What would you do with 1? Plug it in. The point of tangency is the one point that is on both the graph and the tangent line. So you can just plug in 1. What do you get? Perfect. Derivative means slope. What's the slope of this line? Cool. Wait. To get the point, we plugged in 1. It was 1 comma something, so we just plugged in 1. This one's asking for the derivative. The derivative means slope, and the slope of that line is -4. Is that okay? I'm gonna make sure. I'm trying to think of a different way I could say it, but this slope, that's it. All right. The function f has that. How am I going to tell you to rewrite this? The point, -2 comma 7. Just do it. It'll help you know what's going on. Using the table, write an equation. What 2 things do you need for an equation? All right, you have your point. We need our slope. Oh, slope comes from derivative. All right. Our point of tangency is -2. What's our slope at -2? Good. Do you see where that came from? Put it all together. Good? Good job. See how this one's circled? Yep, so you don't have to simplify that at all. It's an FRQ. A differentiable function has the property that, oh, how am I going to tell you to rewrite that? As a point. Oh, and f prime of 3, derivative means slope. So your slope is 3/5. Estimate f of 3.1 using local linear approximation. That means write a line. It means write the equation of a line. Linear means line, okay? So put this all together. What's your line? Three-fifths, parentheses. Yep, we're going to do the squiggles. Y is approximately 3/5. Now, what are you going to plug in? Now, is this one circled?
No.
You're going to have to battle through it to simplify it down because they aren't going to leave the choices alone. You're going to have to figure it out. So we can do it. 3.1 minus 3. Now, what is 0.1 as a fraction? 1/10, right? It is 1/10. Let me say that again in case I lost anybody. 3.1 minus 3 is 0.1. That's a 10th. Now, what do you tack on at the end? Plus 9. All right, now we got to keep on going. Y is approximately. When you multiply fractions, you just multiply the top, multiply the bottom. So that would be 3/50 plus 9. Here's the $1 million question. How many 50ths is 9? How'd you get that? Because that is 100% correct. 9 times 5 out of 0. What's that? It's oh, no mixed numbers. I very much dislike mixed numbers. And then you add them together, so 453 50ths, which is a great answer. Don't discriminate. Right? Do not put a decimal. Decimals are horrible. All right. How can a function not be differentiable? There's 3 ways. Sharp edge. Good. Good. You're saying it before I can even write it. Discontinuous. And then the third one is the one people usually forget. If you don't remember, I'll tell you. But I just want... What kind of tangent line? Because what is the slope of a vertical line? Yeah, by definition, it's undefined. Like by definition, it is undefined. So, and again, there's not a question that says to write those 3 things out, but maybe you'll get a graph. Where is this not differentiable? You know, so you have to know it. All right. Now, if a function is differentiable at some number c, true or false? Does there have to be a point there? F of c exists if it's differentiable. Yeah, there would have to be a point. If it's differentiable, can you get a derivative? That's like the definition of the word, right? If it's differentiable, you can get a derivative. Now, this means second derivative, but have we covered that yet? So it's not the answer. If you come across a word that hasn't been taught to you, it's not the answer, okay? AP pulls together stuff from all over the place, so it's very hard to get questions that are on one tiny little unit because they like to synthesize it all together. So it's very hard for me to separate those things. But if you come across something you ain't never heard of, not the answer, okay? Piecewise function. Are you okay? I'm good. Okay. No, you're fine. I just want to make sure you don't hurt your hand. Does the limit as x goes to 4 exist? You're going to have to go from the left and the right because it's piecewise, all right? Limit x goes to 4 from the left. What do you get? Oh, I guess I should write f of x. Good notation here. What do you get if you plug in 4 to the first piece of the function? -4. Good. And then from the right, you're just going to plug in 4 to the other piece of the function and see what you get. Does it come out to -4? Yeah, okay, cool. So what's the answer? Yes. Is the function continuous? Do the two pieces link up? Yes. We just checked that. All right. Is the function differentiable? Now we're using that x approaches c formula from the left and the right, okay? So limit x goes to 4 from the left. How does the formula start out? The function, awesome. The function minus, which is, we already did it. Negative, can I just write +4? Yeah, okay, cool, you guys are there. Over, now, those cancel, but it's opposite. So it is -1. They do cancel. Do you know how if a numerator and denominator cancel, it's just 1? It's just -1. It was reversed. If you make me, I'll go through every single last step to explain to you how that happened. But what I usually just tell people is it's opposite negative and just go with it because it's more complicated. Okay, cool, thanks. All right, let's do from the right. This one's going to be a little bit of algebra. Okay. It's this second piece of the function, but we're going to have to multiply that out. If you multiply x minus 4 times x minus 4, x squared, where'd I get minus 8x? Minus 4x, good. And then it would be plus 16. Perfect. Minus 4. So that's the function. Then what? What comes next? Minus. Oh, okay. So that would actually be, which is actually good. That's a good thing. Over x minus 4. Oh, I guess I could have left that as x minus 4 squared, couldn't I? Dang it. I didn't realize. I thought we had to multiply it out. Oh, well. Pretend that was still x minus 4 squared. Sometimes you do have to multiply it out. It's not bad that we practiced our algebra, but do you see how one of the x minus 4s would cancel? So if you plug 4 in there, what do you get? 4 minus 4, 0. So what's the overall answer to the whole thing? No. Well, why is it no? They aren't equal. All right. That was a lot of work for no. But here's the good news. Can I make you feel better about it? Was that one circled? Multiple choice.
So we can just split yes or no.
Well, I mean, usually those end up being Roman numerals. Roman numeral 1, function is continuous. Roman numeral 2, function is differentiable. And then A is like Roman numeral 1 and 2. Do you know what I'm saying? Like, it turns out like, I know, I'm sorry. Draw a graph. Oh, wait.
I'm sorry.
No, good.
This is probably silly, but so going back to C, like, so the equation is like f of x minus f of c, and so that's why we did the +4.
Yes.
So -4.
Minus, yeah, it came out negative, yeah.
But then why did we add an additional, like,
Because there's another -4 right here.
on like the other one, like it was, here's what I was even asking now. So hold on, like,
I need to fix this for next year. There were too many 4s. Just go with it, okay? Or I'll answer that once I'm done recording. Draw a graph that is continuous, but not differentiable at -3. Well, what can I put at -3? Sharp edge. It's multiple choice. All right, a differentiable function has the property. Oh, how will I tell you to rewrite this? As a point. Oh, and derivative means slope. Find each of the following or state that there's not enough information. Limit as x goes to 1. Well, what is our point at 1? What does this mean? Derivative, which is 4. Good job. Have we ever done a limit of a derivative? No. So if I haven't taught it to you yet, it's not the answer. Or you could say not enough information. Cool. We're gonna have enough time to play a game. All right. Is the function differentiable at 1? In order to be differentiable, it must be continuous. Good. So can we just do this without writing out the limits since it's a multiple choice question? Okay. If you plug 1 into this piece, what do you get? So limit as x goes to 1 from the left of the function is -4. Do you get what I'm saying? And if you plug 1 into this piece, what do you get? -4. Okay, so can we agree it's continuous? We can jump straight to differentiable. Those both came out to -4. All right. So limit, now here you have to do the limits. Limit as x goes to 1 from the left. It is the function minus what? -4. So it would be +4 over x minus 1. That's going to be a lot of algebra too. Here's a lot, like you can think through this so many different ways. Here's what I would do. I would multiply everything by an x. That is what I would do. To get rid of this fraction, I would multiply this by an x and this by an x and this denominator by an x. That's what I would do. There are other ways you could think about going through that. You can get a common denominator and put things together. Up to you. But these would cancel. You would get -4 plus 4x over this. Now, again, for the sake of not having to write so much, if you were to factor, what would you factor out of that? You would factor out a 4, and that would give you x minus 1. All right, so we'd end up with a 4 over x. And if you plug in 1, 4 over 1 is 4. Okay, cool. Let's do the limit from the right. So it would be the function minus what? So the function minus -4, so +4 over, oh my gosh, what's that going to come out to? -6x plus 6. If you factored out, what would you factor out? A -6? Then you'd have x minus 1. They would cancel. Do you see what I'm saying here? I was trying to do it verbally because I know you've written a whole lot. I'm trying to like help you out here. But what's that going to come out to? Yeah, -6. All right, so this side came out to 4. This side came out to -6. So what's the answer?
No.
No.
That last part was out.
On this side? Oh, if you factor a -4 out of this, then you would get x minus 1. Yeah. Oh, sorry. If you factor out a 4, not a -4. You factor out a 4, you would get -1 plus x, which is the same thing as x minus 1. They would cancel. All right. At 3, if you plug 3 into this piece of the function, we're almost there, guys. Hang in there. If you plug 3 into this piece of the function, what is that? -18 plus -16. Good. And if you plug 3 into this piece of the function, negatives, oh my gosh, are they the same again? We have to do it all over again.
What if we did it? Oh, no.
I thought maybe if they weren't continuous, because do you guys get what I'm saying? If it's not continuous, you don't have to do the next part because the answer is just no. Did I do that wrong in my head? -18 plus 2 is -16. Maybe -16. I'll do it really fast. You guys can just watch.
No.
And you guys can just tell me if I make a mistake. What would that be? -6x plus 18. If I factor out a -6, that side would come out to -6. What is that going to be? X squared, that'd be negative x squared plus 9. That's a difference of squares. X squared minus 9 is x plus 3, x minus 3. If you plug 3 in, oh my gosh, did it come out to negative 6? 3 plus 3 is 6, make it negative. Oh my gosh, then what's the answer? Yes. I did the same thing again. I was just trying, it just gets exhausting at a certain point. They both came out to negative 6. All right. Number 21. Is this function differentiable at 2? What do you think?
No.
No.
From edge.
That is the reason, but it says
One side.
Yep. limit x goes to 2 from the left. The function minus f of 2 over x minus 2. What is your slope from the left side? Negative. That is negative. And you're going to do the exact same thing again. But from the right, what is your slope from the right? Is positive. And that's your explanation. If one side is negative and one side is positive, it's not different. We did one exactly like that in the notes. Do you remember that? Last time, 2 days ago. All right, context problems. A store is selling books. You've been to a bookstore, you know what books are, you know how books are sold. So step away from the problem and understand that you know what's going on, okay? So we've got books, and then what's the other unit? Hours. Perfect, you can read. What does b prime of 4 equals 30 represent? So slope needs the word per. It's something per something else. So I'll start the sentence for you. Books are sold at what rate?
4 per.
30.
30 books per hour at time what? 4 hours. So at time 4 hours, they're being sold at 30 books per hour. B prime of 4 equals 30. What's that? You don't like sentences?
I have zero math. Oh, this is...
There's a 4 and there's a 30. 30 books per hour. All right, work with me. All right, an experiment is conducted on 2 test subjects. One is 5 feet tall, one is 6 feet tall. We've got calories burned as a function of height, how tall they are. We've got feet, all right? What does this mean? So that means the 6 foot tall person, what's happening with them? They're burning more calories. So I'm going to read back how they wrote it on the exam. Okay, so rate of calories, can't talk and write at the same time. Rate of calories per how tall you are, rate of calories per height is greater for 6 feet than 5 feet. Do you feel like that would be true? Do you think larger people burn more calories? Why?
I don't know. Because body.
Oh, what is that?
Hey, cut that out.
I mean, it just sounds like it would make sense, but what does that mean?
There's more biomass.
Oh,
I'm actually good.
okay, you've left what I understand, but I feel like it does make sense. Bigger people burn more calories.